Welcome to Chemistry Live channel. Today we are discuss about the retrosynthesis and synthesis of benzocaine, how we can draw with the help of software in computer. Before the start, I will let you know first, you have to write down the name of the structure and you have to save the file on the name of the as well name of the practical. So the name of the practical is Retrosynthesis of Benzocaine. So first to save the file as a name Retrosynthesis of Benzocaine and then start with this one. Pick the benzene first, okay, then place it in some proper position, then took a CH3 and then use this kind of manual method because it is very crucial to use that kind of manual method for that draw the structure because it helps you a lot and to know the structure. How did you get this? Okay, that is a benzocaine. Write down the name of the benzocaine first here at the bottom. Okay, that is important to write down the name because then you will understand, and I will let you know how to get IUPAC name from that as well, the file as well. So then switch the arrow, switch the bond, it means this or arrow for the retrosynthesis arrow, and then place the arrow in some proper position because it should not look like not good. Okay, yeah, that is the arrow, and here you have to write because then we are switched to the CO disconnection. This CO disconnection because the ethyl group should be disconnected from the oxygen. So here I will write C-O disconnection. Okay, and if I would like to write this CO disconnection, it is good. So then I will get something. So that for that purpose I'll copy the structure like till here, copy it and paste somewhere here because it saves lots of time, and you can see here I'll directly get COOH. How I will get, because I copied till here. Okay, so you don't need to worry about that how I'll get this structure and all. So again you have to draw the arrow and write the functional group interconversion because now we are switching to NH2 to NO2 because there is some reducing agent is there, so we can easily do this. Okay, so here at the top we have to write FGI, functional group interconversion, and if it is not right in a proper place, just drag it and push it some proper places. Okay, better option. The next is to again copy that structure, paste it, and this time you show I will not change anything. So for that purpose you have to delete this NH2 group and then copy from here NO2 because it is important to get NO2 group. Okay, so again you have to switch the COOH to CH3, acid to alkyl group. Okay, so how did you get it? There is another procedure is there. We will take a look on synthesis portion. So it is also called functional group interconversion, FGI. So again draw the line, the arrow, the retrosynthesis arrow, and again put the FGI, then save it again like that FGI, and then if you wish then what did you do? You can again copy the structure. You just copy the structure again and paste it here somewhere, and then you can get that COOH is here. You must have to delete the COH, so delete O and this double bond O, you get CH3 automatically. You don't need to worry about that. Okay, so then again we need to do and remove the NO2. So for remove the NO2 CN disconnection, we must have the CN disconnection from here. This one we should delete it. So again we place an arrow here first to see how did it look like and what is the protocols. So then it is a CN disconnection, that is called CN disconnection, and then this CN disconnection is like that, and then after the CN disconnection copy the whole the structure again. It will save a lots of time. Generally if you are just going to write some publication in a good enough, and then delete the nitro group because we are going to produce the CN disconnections. So after CN disconnection we get a toluene back. So the name the structure toluene manually. Okay, fine. This is the name of the structure, manually. And then we can take a look of another properties of the structures. How did we get the properties? In the toolbar, calculate molecular formula. Okay, this is the molecular formula. And then again, there is a lots of stuff here. Then there is let's called MH plus peak. Then molecular weight. Or formula weight. That is a property which we are talking about. And least but not last, there is a generate the name, and that is very important. Generate the name is very important, that we show if we get the name from that one or not. Okay, this is the structure, and we're trying to generate a name. So it's generate, it's a name to structure, there is no option. Okay, so generate the name, so fine. So that is the parameters, you can get it from here, and it's very easy. And I hope all our guys just understand this stuff well. Please save it before leave the page. Okay, it is very important. If you not save it, then you can lose everything. Just save it at proper place and just make it copy of that one as well. Previously we take a look about the disconnection or retrosynthesis of benzocaine. So according to that, the starting material is toluene. So we have to draw first toluene. This is the toluene, and it is very easy to draw. That is the way. We have to draw one arrow because we have to get the synthesis of the toluene. It is better option to draw arrow, and that is the arrow, the reaction arrow labeling. It is very important. Now you can learn something more, the reaction arrow labeling. So here in that you can take a nitration, and in the nitration under you have to put HNO3 plus H2SO4 or HNO3 H2SO4, you have to put it in this structure. Okay, it's fine, just press OK. Here we got HNO3 H2SO4. So now we are, as usual, use the structure to save our time and put it here. The nitration, it's nitro group always come to the para and ortho position in the case of CS3 because it is ortho and para activating, but the ortho side steric hindrance, so that it comes to the para position, and so we get para nitrotoluene. Okay, from the para to toluene, the next step is to convert CH3 into COOH. It's called oxidation. For the oxidation, we need a strong oxidizing agent, and that is a potassium permanganate, KMnO4. So now we place the arrow. We place the arrow again and use the arrow notation. So we are going to use that bracket and all. Put the O oxidation as mentioned in the book, and then put KMnO4, potassium permanganate. That is, and then convert that CH3 to COOH. Again, we have to copy this structure to save our time. Just copy that structure. And then put COOH. Take it from here, or if you don't want, just remove first this CH3 and took the COOH and place it here. It is very easy. Okay, so this is a para nitrobenzoic acid. Now the another step is reduction, chemoselective reduction of nitro group, because it is very crucial step. In that step we get NH2 at the para position. Okay, that is crucial and important step as well. So then again we have to draw that structure. We can know what is that structure and what is the importance of that arrow as well. So we can draw the structure, the arrow, and use the notation. So here we have to put H2 P, D, C, carbon is called chemoselective oxidation. Okay, we don't need to write chemoselective oxidation, but it is reduction, chemoselective reduction. This is chemoselective reduction. We have to proper place it, and then again copy the structure because it is crucial for us right now. And copy the structure, and then you have to remove this NO2 and place NH2 here to get rid from that one, that structure. Okay, so do like that. It's automatically, when you delete it, it's converted to NH2. So then NH2, now we are switched to the process esterification. Okay, in that case we are use ethanol in the presence of H plus. When we did this, we get our compound. Compound means benzocaine. That is important. That is a crucial step, and you have to take care. Okay, so that point of view, again, just mention the condition in the top right position of that arrow in the presence of ethanol and H plus. Okay, that is only, and again copy that structure. So again copy that structure, and when you copy the structure, we have to again save the time. So please copy the structure and paste it here for the same time. Don't do it routine practice because it is not good. And again you have to draw like that. That is the basically our benzocaine structure. Okay. Thank you for watching. Please subscribe the channel and press the bell icon for more notification.